I'm Rogelia and I'm going to talk about of the Poisson distribution. The Poisson distribution in a probability theory and statistics, the Poisson distribution is a discrete probability distribution that expresses from a frequency of average occurrence the probability that a certain number of events will occur during a certain period of time. The Poisson distribution is used when we interested in the number of times an event occurs in a given opportunity area. An area of opportunity is a continuous unit or a time interval, volume, or any area where there may be more than one occurrence of an event. The number of scratches of a paint car, the number of mosquito bites in a person, the number of computer failures in a day, to mention some cases. The Poisson distribution is applied when you want to count the number of times an event occurs in a given opportunity area. The probability that an event occurs in an area of opportunity is the same for all areas of opportunity. The number of events that occur in an area of opportunity is independent of number of events they occur in areas of opportunity. The probability that two or more events occur in an area of opportunity approaches zero as it becomes smaller. The average number of events per unit is lambda. The formula for the Poisson distribution is P of x is equal to x given that lambda equal to e to the minus lambda power multiplied by lambda to the x power divided by x factorial, where x is the number of events in an area of opportunity, lambda is expected number of events, and e is the base of the natural logarithm systems. The characteristics of the Poisson distribution are mean is equal to lambda, standard distribution is square root of lambda, where lambda is expected number of events. We have a little example. Calculate p when x equal to 2 and lambda is equal to 0.50. Change the value, we have the result as 0.0758. We can also compute the Poisson tables available in lines. First, we have to find the value of lambda and x to have the desired value. We can see that it is equal to the result obtained with the formula. Here we have an example of the graph of the Poisson distribution, where we see that the distribution will depend on the lambda value. Or we can use Excel to obtain the values using the formula poisson.this and substituting the values. Here an example. Now an example. Births in a hospital occur randomly at an average rate of 1.8 births per hour. What is the probability of observing 4 births in a given hour at the hospital? Let x equal number of births in a given 1 hour. With the formula before mentioned and replacing the values we obtained has a result 0.0723. But what about the probability of observing more than or equal to 2 births in a given hour at the hospital? We can pose the problem as p of x greater than or equal to 2. This is equal to p of x equal to 2 plus p of x equal to 3 plus p of x equal to infinity. Or, as we know that the sum of the all probability of an event are 1, we can say that p of x greater than or equal to 2 is equal to 1 minus p of x less than 2, which is equal to p of x equal to 0 plus p of x equal to 1. And substituting, we have 0.537 as result. We can change the size of the interval. Suppose we know that births in a hospital occur randomly at an average rate of 1.8 births per hour. What is the probability that we observe 5 births in a given 2-hour interval? Well, if births occur randomly at a rate of 1.8 births per 1-hour interval, then births occur randomly at a rate of 3.6 births per hour interval. Let y equal number of births in a given 2-hour period, then y approximately PO 3.6. P of y equal to 5, we have to result 0.13768. We can say if x approximately PO lambda on 1 unit interval, then y approximately PO k lambda on k unit intervals. We also sum of the Poisson variables. Now suppose we know that in a hospital A, births occur randomly at an average rate of 2.3 beats per hour, and in a hospital B, beats occur randomly at an average rate of 3.1 beats per hour. What is the probability that we observe 7 beats in total from the two hospitals in a given 1 hour period? To answer this question, we can use the following rule. If x approximately PO lambda 1 on 1 unit interval and y approximately PO lambda 2 or on 1 unit interval, then x plus y approximately PO lambda 1 plus lambda 2 on 1 unit interval. So if we let x equal number of beats in a given hours at hospital A and y equal number of beats in a given hour at hospital B, then x approximately PO 2.3, y approximately PO 3.1, and x plus y approximately PO 5.4. So P of x plus y equal to 7 is equal to 0.11999. Thank you.